Welcome to the debate. Today, we're standing at the foot of the mountains, figuratively speaking, and looking deep into the layers of the Earth. The question before us is really one of history, mechanism, and ultimately time. When we look at the massive geological features of our planet, the high Himalayas, the folded strata of the Grand Canyon, the ordered sequence of fossils beneath our feet, are we looking at the result of millions of years of slow accumulation and gradual tectonic uplift? Or are we looking at the forensic evidence of a singular, rapid, global catastrophic event known as the Genesis Flood?
Yeah, it really is the fundamental divide in how we read the rock record. Is the Earth essentially a history book written page by page over deep time, or is it a snapshot of a chaotic ruin? I'm here to argue for the standard geological framework, the position that the sheer complexity of biology and the physics of mountain building require eras, not months. The rock record is a biography of the planet, not a crime scene photo of a single year.
And I am here to present the alternative perspective. I'll be arguing that the geological column and the topography of the Earth are best explained by catastrophic plate tectonics and rapid sedimentation. I'll be drawing on a lot of recent research published in late 2025 and early 2026, which suggests that mountains actually rose very quickly at the end of a global inundation, and that the fossils we find are not a record of evolutionary development, but rather a burial order determined by rising waters.
It's a bold claim. I mean, you're essentially asking us to compress eons into a single year. I'm definitely ready to dig into it.
Let's begin with our position statements to properly frame the discussion. The core of my argument rests on the physical evidence found in the rock record itself. When we look at sedimentary layers, we aren't seeing local river deposits or small regional floods. We are seeing what geologists call megasequences. These are sedimentary layers that span entire continents, and in some cases, they correlate globally. The source material I've been reviewing, including the analysis in the film Is Genesis History? Mountains After the Flood, highlights that these vast layers contain marine fossils found at the very tops of the highest mountain ranges on Earth.
Right, the marine fossils on Everest, for example.
Exactly. To me, this acts as a primary signature of global water coverage. The mechanisms proposed, specifically catastrophic plate tectonics, describe a scenario where the mountains we see today are the result of vertical tectonics occurring at the end of the flood event, rapidly draining the waters and shaping the world we see now.
I see why you find the sheer scale of those deposits compelling, but I come at it from a very different angle. The standard geological timeline isn't just an assumption we made up. It's a necessity derived from the complexity of what is actually inside those layers. My argument rests heavily on biostratigraphy, the specific order of the fossils. We see a highly consistent progression from simple organisms to complex life forms. This is faunal succession. To me, it is incredibly difficult to explain how a chaotic hydraulic event, like a massive flood, could sort billions of fossils into such a precise, consistent order worldwide.
Which is a valid question.
And furthermore, mountain formation, orogeny, involves immense heat, pressure, and plate collisions that physically require deep time. You can't just crash continents together at the speed of a car without melting everything. Yet we see distinct metamorphic grades that suggest very slow cooling. I argue that radiometric dating provides a sturdy, reliable framework for this deep time, one that flood geology has to completely dismantle to even begin to function.
I appreciate that summary. I think you've hit on the exact friction point right out of the gate, the sorting of the fossils. So let's move into our core debate, starting exactly there. You mentioned that the order of fossils, from simple to complex, seems too neat for a catastrophe. You're asking, basically, why aren't the rabbits mixed with the trilobites if it was just a big washing machine?
Exactly. If this is a turbulent, violent global flood, we should expect a homogenized mix, a fossil hash, if you will. But we just don't see that. We see the Cambrian explosion at the bottom with marine invertebrates, then fish, then amphibians, then reptiles, then mammals. It strongly implies a timeline of development, not a timeline of death. If you throw a zoo into a blender, you don't get perfectly stratified layers of distinct animals. You get a mess.
That's an intuitive objection, and it's the standard one taught in Geology 101. But I'm not convinced by that line of reasoning, because it assumes a flood is merely a blender. It entirely ignores the mechanics of how water actually interacts with a living ecosystem. I want to point you to some very recent work by Nathan W. Mogg, published in the Answers Research Journal in October and December of 2025. He published 2 fascinating papers simulating biostratigraphy to test faunal succession and Biostratigraphy is Inevitable.
I'm familiar with the titles, but, simulations can be tweaked to get the result you want. What does his simulation actually demonstrate?
Mogg didn't just tweak variables to force a result. He built a robust physics engine to model how hydrodynamic sorting, ecological zonation, and animal mobility interact during a rising flood. The results were quite revealing. The simulation showed that distinct fossil ordering styles, what you call faunal succession, emerge naturally. Think about it. The first things buried are the things already living on the ocean floor, marine invertebrates. As the water rises, it overtakes different ecological zones in sequence. You bury the swamp creatures, then the lowland creatures, and finally those at higher elevations. It's not about when they evolved, it's about where they lived and when that specific elevation was inundated.
That's a creative argument, but have you considered the sheer volume we're talking about? We are talking about trillions of fossils across the globe. Simulations are useful tools, but does the fleeing to higher ground hypothesis really account for the strict segregation we see? Why don't we find a single slow-moving mammal in the lower layers, or a fast-moving dinosaur that just got trapped early? The sorting seems entirely too perfect for a chaotic system. A flood, by definition, is chaotic. The simulation might show general trends, but the rock record shows near absolutes.
Well, perfect might be an overstatement of the record. We do find anomalies that are often reclassified by standard geologists when they don't fit the expected timeline. But the general trend is explained by that combination of zonation and behavior. But let's look at the chaos you mentioned. You said a flood is chaotic. I agree completely. And that chaos leaves a physical mark that gradualism simply cannot explain. I'd point you to the Nautiloid Canyon example from the Grand Canyon, which was heavily cited in Is Genesis History. We find a limestone layer containing roughly 1 billion nautiloid fossils.
Right, the Redwall limestone.
Yes, and these aren't creatures that died slowly over millions of years and gently settled to the bottom. The orientation of the fossils shows they were caught in a massive, sediment-laden, hyper-concentrated flow. They were buried instantly, all facing the exact same direction with the current. That requires a mechanism of rapid, catastrophic deposition, not slow, gradual accumulation.
I can grant that mass kill events happen. We see that in the standard record too. Turbidites and massive mudslides occur. A local catastrophe can absolutely bury 1 billion nautiloids. But you're extrapolating a local catastrophe to a global mechanism for the entire geologic column. You're essentially saying every single layer is a catastrophe. However, let's pivot to the rock itself, since you brought up the Grand Canyon. One of the biggest challenges for the flood model is the deformation of these rocks. We see layers of rock thousands of feet thick, folded like ribbon candy in various mountain ranges.
Yes, the folded rock layers. This is actually my second core point, so I'm glad you brought it up. If you look at the tape-beat sandstone in the Grand Canyon, or the folded strata in Utah, discussed in the latest volume of Creation Research Society Quarterly, you see massive strata bent at 90-degree angles. My argument here is straightforward. Rock is brittle. If those layers had been laid down millions of years ago, lithified into solid stone, and then uplifted, they would have shattered. They would be full of fractures, but they aren't. They are smooth, continuous bends. This implies the sediment was still soft-like, wet concrete, essentially, when the folding occurred.
I understand the visual appeal of the wet concrete analogy, but I just don't buy that. Let me tell you why. Geology has a very well-documented explanation for this called plastic deformation or ductile flow. When rock is buried deep underground, it is subjected to immense pressure and heat over long periods. Under those specific conditions, solid rock doesn't act like the cold, brittle rock we hold in our hand at the surface. It becomes ductile. It slowly flows. It can fold without breaking because the mineral grains reorient themselves at a microscopic level. It's a metamorphic process. It's like bending a chocolate bar. If it's cold, it snaps. If it's warm, it bends smoothly.
That is the standard explanation, I agree. that was warm and deep. But here is where the physical evidence actually contradicts the theory. Many of these folded layers, specifically the ones I mentioned in the Grand Canyon, show absolutely no evidence of the heat or metamorphism required for that kind of ductile flow. When you look at the grains under a microscope, the sand grains are not stretched, and they aren't recrystallized. The cementing agents aren't broken. They look exactly like bent sedimentary layers. Paul Garner's 2022 research, Flood Geology Explains Grand Canyon Folds, points this out explicitly. If the rock was solid, it should have snapped. If it was ductile, it should be metamorphic. It is neither. It is unmetamorphosed, folded sedimentary rock. This fits perfectly with the model Dr. Andrew Snelling proposes, where catastrophic plate tectonics caused rapid uplift at the very end of the flood, folding these thick sequences while they were still soft and water-laden.
I would counter that low-grade metamorphism can be incredibly subtle, but let's assume for a moment the sediment was indeed soft. You are suggesting that thousands of feet of sediment were laid down, and then almost immediately the continent shifted violently enough to buckle them into mountains. The energy released from such rapid tectonic movement, this catastrophic plate tectonics, would likely boil the oceans. The heat problem is a massive, unresolved hurdle for the rapid flood model. You can't accelerate plate tectonics from inches per year to miles per hour without generating lethal, Earth-sterilizing amounts of heat.
The heat issue is certainly discussed openly in the technical literature, particularly regarding the cooling of the newly formed ocean floor. Dr. John Baumgartner and others have proposed mechanisms involving supersonic steam jets and rapid ocean water circulation to handle that heat budget. It's an active area of research, and they aren't hiding from it. But the alternative, that these are ancient rocks, runs into an even bigger wall. And that brings us to the question of time itself.
Yes, time. This really is the elephant in the room for this entire debate. Even if you can formulate creative explanations for the sorting and the folding, you eventually have to contend with the atomic clock. Radiometric dating, repeatedly and consistently, places these rocks at millions, sometimes billions of years old. We use multiple independent methods, uranium-lead, potassium-argon, and they generally agree with each other. You can't just wave away the physics of radioactive decay because it doesn't fit a rapid narrative.
I see why you rely on those dates. On the surface, they do seem mathematically consistent, but I would argue those clocks are broken, or at least we are fundamentally misreading them based on false assumptions about initial conditions. The source material provides two devastating pieces of evidence against deep time. First, Dr. Andrew Snelling's 2025 review in Creation Research Society Quarterly on the age dating of volcanic rocks. But more specifically, his work highlighted in the Is Genesis History material regarding carbon-14. We are finding carbon-14 in diamonds, in coal seams, and in dinosaur bones.
And why specifically is that a problem for the standard model?
Because carbon-14 has a very short half-life, only about 5,700 years. It should be completely undetectable after roughly 100,000 years. If these diamonds and dinosaur bones are millions of years old, they should be entirely radiocarbon dead. Yet we consistently find measurable amounts of intrinsic C14 in them. The presence of the isotope directly contradicts the deep time assignment. It's like finding a warm, burning ember in a fireplace that supposedly went out 1,000 years ago.
Contamination is the usual and most likely culprit there. Carbon is literally everywhere in the atmosphere and the biosphere. It's notoriously difficult to get a purely sterile sample. A fingerprint, a breath in the lab, a microscopic microbe, anything can introduce modern carbon to a sample.
They have accounted for contamination with rigorous chemical cleaning. These are intrinsic measurements from deep within the crystal lattice of the diamonds. But if you want something even more tangible than isotopes, look at the biological matter itself. I'm talking about dinosaur soft tissue. Ken Colson's 2022 article, Dinosaur Soft Tissues Still Provide Compelling Evidence of Young Age, summarizes this perfectly. We are finding flexible collagen, intact blood vessels, and osteocytes in dinosaur bones.
I readily acknowledge that is a genuine anomaly. When Mary Schweitzer first found that T-Rex tissue, it shocked everyone in the field. But the scientific community is actively investigating preservation mechanisms, iron cross-linking, for example, that might preserve tissue much longer than we previously thought possible. Iron from the blood can act as a fixative, somewhat like formaldehyde. Finding soft tissue doesn't automatically mean the Earth is young. It might just mean biomolecules are tougher than our initial models predicted.
That's an interesting point, though I would frame it quite differently. To me, that sounds exactly like rescuing the theory. The most parsimonious explanation, the simplest one, based on known biological decay rates, is that the tissue is still there because the animal didn't die 65 million years ago. If you find a sandwich on your kitchen counter that isn't moldy, you don't invent a complex new theory for how bread can last 100 years. You assume it was made this morning. The soft tissue, combined with the carbon-14 data, points strongly to the flood timeline. The iron cross-linking theory actually has significant holes. It doesn't explain how the tissue remained flexible or how it survived inside depositional environments that aren't at all optimized for long-term preservation.
But you have to weigh that soft tissue against the consilience of all the other radiometric dating methods. You're picking the anomalies, a trace of C14 here, some collagen there, and ignoring the massive mountain of consistent uranium-lead dates that confirm the geological column. The standard model explains the totality of the column, the cooling rates of magma, and the observed movement of plates. The flood model offers creative, localized solutions for the anomalies, but struggles deeply with the thermodynamics and the sheer volume of the sedimentary record. You are essentially asking us to throw out established physics to save a timeline.
I disagree that they are just anomalies to be brushed aside. They are systemic failures of the deep time paradigm, and the flood model provides a singular, coherent explanation for why we see marine fossils on the highest peaks, why we see global mega sequences rather than local river deltas, and why massive rock layers are folded without fracturing. Standard geology has to fragment these physical realities into thousands of localized events separated by millions of unseen years. The flood explains them naturally as one interconnected event.
It explains them by invoking a catastrophe of almost supernatural proportions that defies known physics in terms of heat and speed. It's a logically coherent narrative internally, I'll give you that, but it requires suspending the laws of nature as we observe and measure them today.
Oris, it requires acknowledging that the rates of processes we see today, gradual erosion, slow continental drift, are simply not the rates that have always existed. That is the core assumption we are challenging. Uniformitarianism assumes the present is the key to the past. But if the past involved a cataclysm that has no modern parallel, your ruler is just the wrong size for the job.
And that is exactly where the divide lies. Uniformitarianism versus catastrophism.
Exactly. As we wrap up, I think it's highly valuable to reflect on a concept mentioned in the Answers Research Journal regarding assumptions in science. It notes that very often, two scientists can examine the exact same data, the same rock formation, the same fossil, and reach entirely different conclusions based on their starting framework.
That is certainly true. I look at the Grand Canyon and I see millions of years of deposition and erosion, a magnificent monument to the immense age of the Earth. You look at it and see a massive wound in the Earth from a receding global ocean. I maintain that the standard geological model is the most robust, predictable framework we have to understand the history of our planet. It accommodates the complexity of the fossil record and the physics of the Earth in a way that a single year-long flood simply cannot.
And I maintain that the physical evidence, from the unfractured, folded rocks to the preservation of dinosaur soft tissue, cries out against deep time. The flood model, particularly the framework of catastrophic plate tectonics and the megasequence concept, offers a profoundly better explanation for the global scale of the geological features we actually observe. It's not just a story. It's a rigorous scientific model that fits the hard data.
It's a debate that forces us to look much closer at the world around us, and that is always a good thing for science.
Indeed it is. We leave you, the listener, with this final thought. When you drive past a road cut or hike a mountain trail, ask yourself what you are really looking at. Is it a clock ticking away millions of years of slow, unobservable change? Or is it a vast graveyard, a global memorial to a catastrophe that violently reshaped the world? The rocks are there. The interpretation is yours to explore. Thank you for joining